in the previous lesson we have talked about the ionic compounds. So move to the slide number 2. We are going to talk about the ionic compounds and what type of elements are involved in making the ionic bond. So Shan, can you tell me a little about the concept of ionic bond? What is actually an ionic bond?
Ionic bond.
Yeah.
An ionic bond is it's like the magnetic attraction between two ions that are oppositely charged.
Yeah, very good. So you should say that the electrostatic attraction, right? Electrostatic attraction mean the type of attraction that is present between the charges. So the charged particles always have electrostatic force of attraction. So we have studied that if we talk about the ionic compounds, so they are made up of the anion and the cations. So because of the opposite charge, so these ions have an electrostatic force of attraction, and that force is actually the ionic bond. So can you give me example of any ionic compound that we have studied in the previous lesson?
Ionic compound.
Yeah.
I don't remember any.
Shan, one of the best example of the ionic compound is the sodium chloride. It's the table salt that we use in our kitchen, that we use in our food. So sodium chloride is one of the good example of the ionic compound, and we have studied that if we talk about the structure or the composition of sodium chloride, so it exists in this form. It is made up of sodium with a positive charge, and it is having the Cl with a negative charge. So it means sodium is present as sodium ion, and in the same way the chlorine is also present as the chloride ion. So we also talked about the dot and cross diagrams for the sodium and chloride. So today we would try to build the dot and cross diagram for other types of the ionic compound. Just like if we talk about one other good example of the ionic compound, so that can be considered as the calcium chloride. So here you can see that if we talk about the calcium chloride, so there is one calcium ion and there are two chloride ions in this ionic compound. And I told you in the previous lesson that whenever we are going to talk about the diagram, the dot and cross diagrams for various ionic compounds, so what we have to do, basically we have to show the atoms as the reactant, and we have to show the dot and cross diagram for the ions as the product. So first we start with the dot and cross diagrams for the reactants. Okay, so Shan, if we talk about the calcium atom, so suppose I am drawing this one as the calcium atom. So can you tell me that how many electrons are present in the outermost electronic shell of the calcium atom? You can take the help from the periodic table.
Yeah, okay, one sec. I'm gonna open it. Calcium.
Yeah. So according to you,
Outermost shell.
how many electrons are present in the outermost electronic shell of calcium atom?
2.
2. Okay. So suppose I am showing that with the help of the cross. So these are the 2 electrons in the outermost electronic shell of the calcium atom. And as you can see from the empirical formula for the chlorine, that there are 2 chlorine atoms. So suppose this green circle represents the 1 chlorine atom, and as you can see there are 2 chlorine, so we would try to draw the 2 chlorine atom. So this is the second chlorine atom. Okay, Shan, from the periodic table, let me know that how many electrons are present in the outermost electronic shell of the chlorine.
Chlorine.
Yeah.
17.
No, 17 is the total number of electrons. You have to tell me the number of electrons in the outermost electronic shell of the chlorine.
Okay, into the outermost shell there are 17 including, so there's one.
No. If I ask you that the proton number for the chlorine is seven. Very good. So 7.
Yeah.
So I am representing it with the help of the dot. So 1, 2, 3, 4, 5, 6 and 7. So in the same way,
Yeah.
I would represent the 7 electrons for the other chlorine atom. Okay. So now if we draw on the product side, so as I told you that the atoms would be taken as the reactant and the ions would be taken as the product. So Shana, I told you in the last lesson, because here we can see from the electronic structure that every chlorine atom is having 7 electron and it needs one more electron to complete its outermost electronic shell. So what happened, this electron would be given to one chlorine atom and the second electron would be given to the other chlorine atom by the calcium atom. So it means that calcium atom is losing both of its outermost electrons and nothing would be left in the outermost electronic shell for the calcium. So we can draw the calcium ion as this one, calcium. How much would be the charge on calcium ion?
The charge on calcium ion,
It has lost 2 electrons.
yeah, so it will be -2.
No, not the negative. Electrons are being lost. So whether it would be a negative charge or positive charge.
Yeah.
So which type of charge would be there?
Positive.
Positive. So keep in mind that whenever an atom loses the electron, it gains positive charge, and whenever an atom gains the electron, it bears negative charge. So 2 plus charge. Okay. And there are going to be 2 chloride ion. So in order to show the chloride ion, this one square bracket, this circle representing the electrons for the chlorine. Okay, so the electrons for the chlorine can be represented with the help of dot. So 7 dots, 1, 2, 3, 4, 5, 6, 7. But one of the electron represented with the help of cross.
Yeah.
And minus charge at the top of chloride ion, showing that it has gained 1 electron. And the second chloride ion would be represented in the same way. This is Cl, so 1 cross and rest of all would be dots. So 1, 2, 3, 4, 5, 6, 7. Okay. And 1 negative sign. So Shan, this is the dot and cross diagram for the calcium chloride. Okay. So now jump to the next one slide.
Yeah.
Okay. So suppose another important example of the ionic compound, that is the magnesium oxide. So this is also an important example of the ionic compound, and we have to draw the dot and cross diagram for the magnesium oxide. Okay. So first of all, we would try to draw the magnesium atom. Shan, how many electrons in the outermost electronic shell of the magnesium?
In magnesium?
Yeah. Have a look at the periodic table.
Yeah, 2.
2. Okay. Because the magnesium belongs to which group? What is the group for the magnesium?
The group?
Yeah, group number.
The second
Very good. So an atom present in the second group of periodic table would be having the 2 electrons in the outermost electronic shell. Shan, the second atom is oxygen. Have a look at the periodic table and let me know how many electrons would be there in the outermost electronic shell for the oxygen.
Oxygen.
Yeah, 6. Very good. So 1, 2, 3, 4,
Yeah.
5, 6. Right? So
Yeah.
have a look at the electronic structure of the oxygen and let me know that how many electrons are required by oxygen atom to complete its outermost electronic shell. 2. It has already 6 electrons, but it wants to acquire 2 more electrons so that it can complete the octet. So this electron would be given to the oxygen,
Yeah.
and this would also be given to the oxygen. Now we can draw the product side, and we have the magnesium atom. Okay, so we can still show the magnesium as a circle just like this one. This is our magnesium, then a square bracket, no electron because the 2 electrons have been lost by the magnesium atom. And how much would be the charge on magnesium ion?
The charge of the magnesium ion.
Yeah.
It will be -4, right?
Shan, how it would be -4? You can see
-2 or +2.
You can see that magnesium has given 2 of its electrons to the oxygen. And I told you in the previous example that whenever an atom loses the electron, it always gains positive charge. So the charge on magnesium ion would be 2 plus. Okay.
Yeah, 2 plus.
Then I am going to represent the oxygen as ion. That is the oxide ion.
Yeah.
Okay, so this is oxygen, and I have the 6 electrons represented with the dot. So 4, 5 and 6, and you can represent the rest of electron 1 and 2.
Yeah.
How much would be the charge on oxide ion?
On the oxide ion,
Yeah,
it would be -2.
very good. So this is the dot and cross diagram for the magnesium oxide, right? So
Yeah.
okay, goodbye. In the previous lesson we have talked about the ionic